Oh boy, more sketching. All right, this one's a little more complicated, and it's telling us to sketch a polynomial. And you probably remember from last chapter that if we have a polynomial like this, we know that it changes directions 4 times, which means it's x to the power of 4, which means it's got 4 different. No one cares. No one cares anymore. Well, not for now. All we care about is what the relevant points are and how they're going to act when we flip them. So we've been given y equals f of negative x. So you can take your little, and I encourage you to put this onto your own cheat sheet because this is super handy. But I'm going to look at this and go f of negative x is in this quadrant, which means that my y values are going to stay the same, but my x values are going to flip when I'm going to be reflecting this over the y-axis. That's what f of negative x means. So y values are the same, x are going to change. Now, we can write that. Y same, x change. Remember delta? So we have listed the points here. I've got negative 4 and 0, negative 3 and negative 64. Ooh, they're all fancy with making these numbers big. Watch that actually, because sometimes it actually will mess you up because they're not out of the same thing that you think they are. So just be cautious. Negative 2 and negative 64 goes on to, I think we skipped one here, but 0 and 0 and so on and so forth. So, yeah, that's funny. Whatever, it's all good. So what we're going to do is recognize that when we have y equals f of negative x, then we have to change the value of x. So that means when we make our new points, we're going to make a list of whole new points here, changing the value of x. So the first one's going to be 4 and 0. Next one's going to be 3 and negative 64. The next one's going to be 2 and negative 64. 0 and 0 stay the same because, well, it's kind of obvious. Negative 2 and 32 is going to be our new point here. Negative 4 and 0. Negative 5 and negative 16. And negative 6 and 0. So now we're just going to plot those points. We've already switched them, so let's go. Yeah, that's going to do that. So 1, 2, 3, 4, 1, 2, 3, 4. Turns out this point, because we had a negative 4 and 0 here, and we also have a negative 4 and 0 here, it's actually not the same point. It's this point becoming that one, and that one becoming this one. But we will have points in common there, so you kind of have to watch out for that. And then we'll have 3 and negative 64, so this one is going to still be at 3. I keep messing this up. 3 and negative 64 goes this way, and negative 64. So you can see that my axes aren't perfect here. But this point is now going over to this point. And then this point will go over to here. And now we've got one there. This stays the same, so it's going to be in common. And then I've got one that comes this way. And then that's where this guy turns to this. And then I've got this guy who is just 2 dots over here, and that's my negative 6 and 0. So I've also got this point, which is negative 5 and negative 16. So that's going to be here, because it used to be 5 and negative 16. So then I very skillfully connect my points. Without too much mucking around. Sorry, but that was ugly. I've got a reflection. This bumps now here, this bumps now there, tail ends and all that. So the last thing to do is to determine the domain and range of each one. So for the original equation, I can just look at these and I can see that my range, sorry, sometimes the the words get mixed up. My domain is my x value, and it goes from 6 to -4. But if you look at the graph, it's actually just going on forever. So I'm just going to write x is in the realm of all real numbers here. Sorry, I just took a minute to check and make sure that they weren't doing anything weird. But yeah, the x didn't change in terms of it just goes on forever both ways. However, the range actually caps out right there, and your book approximated that at about 68. So that means that y is going to be greater than or equal to 68. Sorry, -68. And it's going to be the same for both functions because it flipped this way. So for this particular graph, the domain and range before and after stay the same. Even though the x values changed, x is in the realm of all real numbers, so it doesn't matter exactly where they are, they're just ongoing in this case. So that's kind of, I don't know, can be a little sticky. The easiest thing to do is just to actually look at the graph and go, okay, well, what's happening on the graph? Just know they do tend to change depending on what you're reflecting and what shape your graph is. So it depends, it depends on the individual graph that you have. You have to assess it each time.